seeing my screen, what do you see? What do you see? I need some few feedbacks. What are you seeing on my screen?
Graphing.
Okay, graphing.
It is a GeoGebra interface.
Okay, that is very good. Hope everyone is seeing that, and that is also what I'm actually representing right now. Okay, so let's get started. This is actually the interface that we shall basically be playing around with as we try to write our projects or do anything that will help us learn our mathematics or teaching. Now here we have the input section. This is where we have the algebraic view of anything that we are trying to present. Then this is the graphing part of it, where we shall be where we shall do plotting of graphs. If you're very keen enough, you'll see the x and y axis clearly drawn here. Yeah. So let's get started with what we have today. So as I told you guys before, that today we shall explore more of transformation using GeoGebra. Even towards the end, I'll also try to show you how you can do linear transformation. I think linear transformation is taught in year 2. That is linear algebra 2. So you'll also get to realize some of the few things that you guys have been studying also here in this particular training. So let's get started with the very basic. So so when I go to tools and then I try to create some polygon, I can create a polygon. Let me go to the polygon app. Okay, click on more. Then okay, there we go. So we have polygons here. So you can choose between the polygon. This is an irregular one. This is a regular polygon that all the sides are equal. So our major target is only to talk about any figure. So let us click. This is our first point, second point, third, fourth. Okay, so there we go. So this is our particular polygon that we shall deal with. So maybe we are interested in trying to transform it into very many ways. So when you turn to the algebraic view, algebra, you find out that all the details of this particular polygon is here. Basing on the points, these are the points. Then this is the name of the polygon. It's called poly 1. So GeoGebra automatically attaches some name on different figures that you have drawn. So this is poly 1. So if you draw the second polygon, then maybe it would call it poly 2, just like that. So these are segments, the A, B, C, up to E. Those are segments that make up the polygon. Yeah, so that is the the algebra view. Now, let us try to do some few transformations onto this particular polygon here. So let's go to the transformation. Let's see. Okay, this is transform. Now, these are some of the tools about transformation. So when you're doing transformation, you can decide to reflect. You can decide to rotate around some point. You can reflect also above some point, or delete, and or transform it using a vector. So we shall explore all these components today, these few components that you're seeing here mainly, and this will guide us up to the linear transformation, actually. So let's start with the one here that is reflecting about a line. So which means for us to do this particular transformation, which is reflection, we actually first of all have to be having a line. So before we click on this, let's first go and create our line. You click on the line tool. So let's have the line drawn around here like this. Okay, this is our line that we need to reflect. That's our mirror line actually. So we can now go and activate our reflect about a line. Then it's telling me to click the object to reflect, then the line of reflection. So this is a particular object I want to reflect. Then this is my line of reflection. So immediately you see something reflected there. So you can try to play around with it. Let's go to our move tool. So whenever you want to adjust something, please make sure you activate this particular icon here. So this is the move tool. So we can try to move around. Suppose we make this one longer like this. You see what is happening with the image. This is the object, this is the image. So you can try to play around. Okay, let this one be here. So you see what is happening with the tool. Okay, once you change the object, you see what is happening with the image. So when you want to change the image itself, it will refuse. Right now I'm trying to click on the image and wanting to change it, it will refuse. So which means that you can only change the object, and what you get as an image is entirely dependent on the object. Okay. Yeah. So this is just a very basic concept about reflection about a given line. So okay, let me first turn to the okay, let us continue. I was still trying to check something a little here. Okay, so this is a very basic concept about reflection about a given line. So you can try to, if you're trying to teach reflection, which is one of the topics in senior 1, senior 2 there. So when you have your software and you try to project it, then you try to play around with this. This will help the learners to also get to know what are the properties of reflection. So you realize that maybe you first let them calculate the distance between this is our origin up to this one. The distance is around 4. Then if you try to also check for this and this, then the distance is also 4. So you can also keep on checking between this and this, what's the distance? Between this and this, what's the distance? So you realize that the distance from the mirror line up to the object is the same distance from the mirror line up to the image. So these ones, students are able to explore some few concepts. Now, this might look a little bit boring because I'm trying to deal with some given figure. The figure that we could not be knowing its real name, but it has 5 sides. Now, let us first try to interact with physical pictures. Now, let me first delete this. Those few basics. Okay, so I wanted us to first upload some picture into our GeoGebra software. Then we first try to see how we can also do the same thing that we have been doing to this particular image or object. Let's try to do the same thing. Okay, so let me first delete the whole of this, clear and discard. Okay, let me get some picture from online very fast. I need cartoon. I need cartoon rabbit. Okay, I have just gotten the picture right now. Let me name it rabbit. Okay, save to desktop. There we go. Okay, so I already have one picture here in my desktop gotten from the internet. So let me upload it into my GeoGebra interface. So I hope everyone is seeing this picture here. Mr. Wanjala, are you seeing
Yeah,
something?
the picture is seen.
Okay, that is good enough. Hope everyone is seeing it. So with this picture, this is actually a picture of some cartoon rabbit. I got it from the internet, and there are very many other pictures that you can play around with. But with me, my major interest is on this one here. Now, what I will do, I'll try to do some form of reflection onto this particular picture. Uh, Still reflection about a line, so which means we need some line of reflection. So let me get a line. Um, the line is here, so let me reflect it along the line. Uh, this is x is equal to -1. There we go, that's our line. So when you go to the transform tool, then we come and activate reflect about a line. Then it's telling us to click the object, select the object, and then the reflection. So this is about the object. We shall select the whole thing here. This is our object. Then the line is this line, which is x is equal to -1. So there we go. So this is our particular object that we have actually reflected. So you can try to play around with this. You can adjust the object, make it bigger, make it tilted a little bit. So you realize that the same thing that you do with the object, the same thing that is happening with the image. Now you can also try to calculate the distance. Let us first create those distance. Let me go to segments. Segments are here. So suppose I want to get the distance between this one up to this. Then I compare it with the distance from E up to A prime. So now this is when you are basically in class, then you're trying to play around with the student's mind. What will the distance be? Maybe you could first let them guess what will happen to this to these two distance. Then you can now use your GeoGebra to just prove it that all those two distances are correct by coming to the measure. Then you click on distance. So click from here to here. That is 2. Then from here up to still E, that is still 2. So which means that there are equal distance between the object and the image. And anything that happens with the object, it also affects our image as well. So sometimes you can also do double reflection. This is the first reflection. You can also again create some other line. Let us create another line, then we do reflection onto the image that we had formed from the object. So let me get line is here. So maybe this time I want to reflect it along the line. -1. Y equals to -1. So in this case now, we still go and activate the same button, which is reflect about a line. Then we select the whole object. This is the whole object that we want to reflect. Then we click on the line. So, okay, it did not show the object. It's only showing the point A and B. Okay, let's first do it again. So, reflect tool is on. Select the whole thing here. Then you click on the line. Okay, there we go. So I think it has come out clearly. So in this case now, we have double reflection. The first reflection is from this one, which is AB, is actually being reflected. Let me first activate my move tool. This particular object here is reflected along the y. So the line y x is equals to 1, I mean -1, for us to get this image. Then this image is double reflected again to form this. If you're very keen enough, if you can remember in your O level, something close to this also was tried to discuss with you. You would draw some graph to show some figure being reflected once and also reflected. That same image that was formed due to reflection is again reflected also along some other line. Then they tell you to find the coordinates of the second reflection. So this is actually what you play with. At least this one here is really more interesting because someone is looking at a picture and the picture is really being reflected, and so this is what you can do in class. I want to show you again one more interesting thing about reflection basing on this particular object. Now, let us first interact. So, I think, let me call one of you. Let me call one of you. Okay, I'm seeing Okello. Okello quiz. Yes, Okello, can you hear me? Feel free, turn on your microphone. I just want to interact with you a little.
Yes, I'm picking you well.
Okay, Okello, I just want to ask us to share something very little. Do you know about lines of symmetry?
Line of symmetry? Yeah.
Yes. Okay. So how many lines of symmetry are in a square?
A square is having two.
Oh, two. Two. Okay.
Mm.
The first one. How many?
I'm saying two.
Okay. That is very good. But a square has actually four because I think a rectangle is not having two. A square has four because you can divide it here and on there. Anyway, that's not my major emphasis right now. But my major emphasis is on the line of symmetry of a human being. How many?
Human?
Yes, human beings.
For a human is two.
Is two. How can you divide someone?
Vertical and horizontal.
Okay, now let
For
us get to
human
prove
being is
that.
one.
Let us get to prove that. Let us get to prove what Okello was telling us using GeoGebra, okay? Because seems to
Okay.
be some serious challenge that we have to solve. Now, this is a student and teacher interaction now. You're trying to interact with the students. Students can try to give you some answers. Of course, what they're giving you is not wrong. Everything that a student tells you is right. Okay? On that, you have to make it clear to them and make them understand from that particular thing or answers that I've given. So, basing on Okello's question, let us prove it using GeoGebra. Now, what I'm going to do, let me first clear out this particular interface. So we are now clean here, okay? Now, what I will do is I'll try to bring a half a human being. Then a half a human being, then I'll try to reflect and see whether I'll form a full human being from a half a human being. Then I'll also try to bring a quarter a human being. Then I'll also try to reflect here and there to see whether there are really two lines of symmetry. So pay keen attention. Now let me first go to my desktop and edit some few picture here. Okay, this is the cartoon rabbit still. Let me edit it. Okay, so editing crop. Are you seeing what I'm editing? I think you people are only seeing my GeoGebra page only. What are you seeing, Wanjala?
I'm seeing on the GeoGebra page.
Oh, okay. What I shared is on the GeoGebra window only. It's okay. Worry not. I'm just going to show this very soon. Okay, so I've already edited my picture. Let me save it. Save. Okay, save it to desktop. So I already have my image here. Let me share it on the software. Okay, can you people see something?
Yes.
I'm seeing.
Okay, you're trying to look at some rabbit, half a rabbit, no, sir?
We are seeing something on the screen.
Okay, so let me. Okay, this is what we have. This is a half a rabbit. Now, what I will do, I'll first try to reflect it. I'll try to reflect this particular rabbit and see whether I'll form something which is similar to a full rabbit. Now, this is very close to lines of symmetry because lines of symmetry are basically lines that divide a certain object into two equal parts. So I just have my half rabbit here. I want to try to reflect it about some line. So let me get that line very fast. Go to tools and lines. Okay, here we have lines. So let me reflect it along the y-axis. This is our y-axis. Okay, this is y-axis. Okay. So go to reflection about a line. Reflection, that's transformation, where? Okay, it's here. Now it's telling me select the object to reflect, then the line of reflection. So this is my object to reflect. The object to reflect is here. Then my line of reflection is this one here. Oh, what do you see? I need someone to
A full rabbit.
a full rabbit, okay? You see, at least I got a half a rabbit, then I reflected it about some axis. And you're seeing a full rabbit being formed, right? So this is actually what we talk about under lines of symmetry. So you realize that you can divide this rabbit into two equal parts. Now, Okello was telling us we have two lines of folding symmetry. Now, let us first of all try dividing this rabbit into a quarter. So which means this our line, we shall divide it around here. I'm not sure whether this is a quarter. This is. So suppose we divide it only have this other particular thing here. Then we try to reflect it along here and then along down here. Do you think we shall put another rabbit? Let's first see. Okay, let me see line. Okay, the line is off there now. So let us first try to compare this particular image that we formed by reflection with this one that I'm going to upload next. Where is it? Oh, there were two. So can you see this? There's this one and this other one. So I think there is some few difference between these two images. Okay. So maybe the difference could be on the hair, that here it's having three designs in the hair, sorry. Then here I'm looking at only around 4 because of reflection. But once you see them from a distance, you might realize that these are the same images. Yet this one actually was created by reflection. So this is actually demonstrating that this particular image only has one line of folding symmetry, which is formed by bisecting it. Okay. So maybe let us first try to prove Okello's issue. Okello said that there are three. That there are that there are two. Let me first try to edit the picture again. Edit. Okay, let me first try to upload this. Let me delete this. discard. So, Okelo, what are you seeing? Okelo, Chris.
I'm seeing a quarter of the head.
Okay, you want to, because I divided the picture into two, okay? Because what you're trying to
2 for
study is, let me first upload the picture as well. This is the picture that we're trying to study together. And we're talking about its line of folding symmetry. So at first we saw that when you upload a half, when you upload a half of the picture, we can reflect it along some given line. Then we can now be able to form the full picture due to reflection. Now here we have a quarter of it. Now this one here will answer Okelo's question carefully because Okelo said that there are two lines, which means we could divide this one from here or divide it like this as well. So let us try to reflect it now. Tools, line, and I need to create two lines. My first line is this one and this one. My second line is this one and this one. So reflection, you can try to reflect, transform, reflect about a line. So the whole object is here. Then the line is here. This is at least showing the head properly. Let's now see whether it will bring for us the legs. So we are still going to reflect about a line. Then the object now, it is all these two. Then the line of reflection, it is this other second line, which is drawn on AB. So you see, what you're seeing here is not actually what is here. So, John Mark, could you see what is in our screen right now?
Yeah.
So what do you say about it?
Actually, it's a reflection of only the head.
Okay, it's only the head which it has been reflected. Okay. So
Yeah.
what do you conclude about it, about lines of symmetry of this particular rabbit picture here?
To me, I see like it has only one line of symmetry.
Okay.
Eh,
Yeah, I think that is very okay, and that is actually the line of the symmetry of this particular rabbit. So this one here, we tried whether it has two, but you see that some other, the legs are not being formed here. In case it is the upper thing which is formed here. So these are the discussion that you can do in class with your students, and later on, they get the exact proof that exactly this one has one line of symmetry. And trust me, something like this can never get off your mind very fast. It is more better than someone who just come and say, a human being has one line of symmetry. The square has four. A rectangle has two. So you're trying to just say something that, and not putting something that will make the students remember very fast, okay? So let us try to use this interactively in class. Then the students will actually be able to like it. So you can also do the same thing for the square. You can draw a big square, then divide the square into two, and try to translate it by reflection onto some lines and see whether we can form the square again. Then you keep on interacting with your students until when they come to a conclusion that about what you're trying to teach, okay? Yeah, that is actually reflection, and I hope you guys have enjoyed reflection. I hope you guys have enjoyed reflection. I want to go to a different transformation. Am I good to go? I need some signal from the team online. Yes, LM Billy. I give you some.
Okay, according to me, I feel like you have given us or the starting line. So the more that we may get to know is just through exploration, bit into what we will have like in the app we have. So I feel like it can prevent us from continuing into another session. Thank you.
Okay. Thank you very much, Billy, for that submission. Let us continue into another form of transformation. That was basically reflection, and you saw how interesting was it. We were interacting together in a class, and yeah, at least we came to some nice agreement, and everyone is happy about it. So let us go back to our software and first clear off all this. Let me clear the whole of this card. Okay, there we go. So let's go to another form of transformation. Now, I want us to do transformation by vectors using GeoGebra. So let us start with a simple figure, maybe a simple polygon. Let me see. Okay, maybe for my polygon here, don't mind about the shape. I just want to create this shape. It's just a random shape. It has no issue to deal with. You don't need to over question this. So the shape is what I want most is the concept behind it. So let me try to improve on the coloring. You can go on the coloring and increase the opacity, and maybe choose a brighter color, which is let's say light green. Okay, let's see what. Yeah, this is our figure now. So I want to do transformation by vector. So let us go to our transformation. Yeah, so under transformation here, we have transformation by vector icon here. So when you click on it, it will guide us on what to do. Select object to translate, then vector. So we have to first start by selecting our object. So which means I want to select all of this. So this object here. So we shall translate this figure or a polygon that we have drawn. Then next is our vector. The vector could be let's say from we just want to go on the, because vectors are given by x and y. You move x step and then y step. So I want us to move with this figure. I want us to move from 6 here. We shall move around let's say 3 steps to x, then 2 steps downwards. So it is this to this. Okay. Let me first undo it and start afresh. Okay, we activate translation by vector, then we select the object. This is, sorry. Select this, then the object to translate is this. Then the vector is from negative. So we want to go in the x. Let us move 3 steps. This is the first step, second, and then this is the third step. Then downwards we move to 1, 2. So this is our vector now. So the vector in that case is 3 in the x, then 2. So let's see our figure now. Let us see our figure. Now let us see our figure. Okay. So what you're seeing here, it's the image. Is the image of this particular. This is the object, and this is our image. And this image is formed due to this translation. So which means all the points. Let me first adjust. So if you look at point D, this is point D, and then this is its image. So which means that this point D was moved 1, 2, 3 steps, then 1, 2 downwards. That's how this particular vector is moving. So if you try to adjust this vector, you see what is happening. So now this is moving 3 by 3. You're moving 3, positive 3, then negative 3. So this is the image that we shall get. So when you look at 3, I mean C. C, it has been moved 1, 2, 3, then also downwards 1, 2, 3. So everything is actually based on this particular vector here. This is what we call translation by vectors. So it's also one of the things in the O-level syllabus of Uganda. So you can also try to do this. Trust me, you can also do it in the same way how I did with reflection. You can try to move a given image into your software that you demonstrate on the blackboard. Please try to use also GeoGebra. Try to use also GeoGebra to make them more interesting, to make the concept more interesting. Yeah. Let me have this is Cyrus. Cyrus, can you hear me? Yes, Cyrus, you can open up your microphone. I want to just interact a little with you. Yes.
Yes, I'm getting you.
Okay, that is great. I hope you have seen transformation by vectors. Okay.
Yeah, I've seen.
Okay. So do you want to tell me that when you're given that particular object that we had at first, the other object which was of a rabbit, you can also translate it using the same idea?
Yeah, I think so. You can also transform it in the same idea.
What I want us to do next is now let us discuss linear transformation. Linear transformation using GeoGebra. Linear transformation, I want to talk to someone in year 2. Someone in year 2 to first give us some brief background about linear transformation. What is it all about? Let me see. Someone linear transformation is taught in year 1 and year 2. I mean year 2, semester 1. So maybe okay, anyone who knows about linear transformation, first tell us the background about linear transformation. We shall really appreciate that. Linear transformation. Okay, Wanjala, you first unmute your microphone. Wanjala, please unmute. Unmute, you want to talk. Okay, Wanjala, do you know about linear transformation? Okay, Joshua has something to say. Joshua, first say something.
Let me talk about the linear transformation a bit.
Okay.
In mathematics, the linear transformation is also actually called the linear map or linear operator.
Okay.
It's a function between the vector spaces that preserves the operations of vector addition and scalar multiplication. It takes a vector as the input, and it can also actually produces other vectors as output.
Okay, that is
They also
great.
preserves the linear relationship between vectors.
Okay, that is very
I
good
think that's
enough.
what.
Wanjala, you're saying something.
Actually, it's the same knowledge I had. Uh, just a function between it can be between vectors, like he said, vector spaces, and preserve the operations of vector addition and also scalar multiplication.
Okay, that is very good. That is very good. You see, now if you're teaching that one there, and you're speaking about scalar multiplication and preserving the They're just all those properties. You realize that sometimes it's not very easy to remember it, but you need to do something that is practical enough, and someone really appreciates. Now, the two people who answered about linear transformation, or yeah, linear transformation, I want you to agree with me that in linear transformation we always have a matrix. Is it true? Do we always have a matrix in linear transformation, Joshua?
I think, yeah, we always have a matrix in linear transformation.
Yeah, so it is a matrix that you multiply with the vector to get another image, okay?
Yes, yes.
Okay, that is very good. So let us look at how GeoGebra does that. Now, this is our page, and it's actually a fresh page of GeoGebra. So we are going to do a little bit of linear transformation. So let us start by creating our polygon that we shall transform by a matrix. So polygon. Okay, there we go. It is here. I'll create any figure. Let's say right now I want to create a figure that goes up, comes down, a bit straight. This one goes in. Okay, this is my figure. Let me first make some little bit of editing. I want to try to change. I want to try to improve on this color so that it's clearly seen. So the color here, let me change the color. The color here is okay. Let me give it a blue color, a solid blue color. Then I increase on the opacity. Okay, there we go. So this is my particular figure. Now, let us try to create some vectors. Let's try creating some vectors. Let's try creating some vectors onto this particular solid written. So the vector, our first, okay, go to vectors, vectors. Okay, this is the vectors. So we shall create a vector that links this one, the origin to A. Then create another vector from the origin to B. Another vector from the origin to C. Another vector from the origin to D, and the same applies to E. Now, these are our vectors. If you want information about them, then you come to the algebra and you see all the information. So poly 1 is our polygon. Then this AB are the segments that makes up the polygons. Then you're seeing that there are there are vectors here created. These are the vectors that have been created. U, V, W. So those are all the vectors that I created. Okay. So I want to design some form of project that will help me explain transformation by matrix or linear transformation. Now, from this now, what we have to do is to first create some matrix. Let me create some matrix here. If you want to create a matrix, then you come to the input. You can just give it a name, matrix. Matrix equals. Now, the way you write a matrix in GeoGebra is a little bit different. You have to give it a bigger bracket. Then those entries, you have to actually put them into brackets as well. So let's see this one. Maybe 1, the first entry should be 1. The other one should be 0. Then we go to I will go to the second column. In the second column, we want the first one to be 0. Then the second one should be 1. Let's hit enter. Okay. Hope you are seeing the matrix which has been formed here. What name is given to this kind of matrix? What name is given to this kind of matrix? Yes, Aaron?
Identity matrix.
Yeah, that is very fantastic. That is what we call an identity matrix under matrices. So now this matrix here, I'm going to multiply it together with all these vectors. Let me start multiplying it one by one. So I want to multiply it with vector G. I'll open brackets, then multiply with matrix. So because it is called matrix, then I'll just type there matrix. Then also multiply it with this matrix. And do the same for W. Please be taking some few notes because it will help you to also try to practice the same things. Matrix. Open brackets, matrix. So the name of our matrix is matrix. That's how GeoGebra will actually identify it. So let me see. Have we done it to all the vectors? This vector is not yet. Let me also do the same to vector U. Open bracket, matrix. Okay, so you can now see all the vectors U, G, F, W, V are being multiplied by a matrix, okay? Okay, so now what we shall do next is now, let's first try to silence. Now, we want to create the image that will be moving. This is the object here, and then these are the vectors. So you want to be creating the image that will be moving. Right now, you're not seeing this object moving because actually our matrix here is an identity matrix. So it actually has no object. I mean, it has no effect on our object at all. But if you try changing this particular matrix here, then you'll see it also, like the object will also change from here. But before I start changing this matrix, let me first create the image that will, the image that will remain at the same point, then we shall keep on moving the other one. So let me first silence this particular polygon. Then I also try to silence these other figures. Let me silence these other figures as well. Then, okay, let us create some other polygon. So go to the polygon tool. It is here. Then go from here. Then we hit somewhere. So that at the tip. Okay, so this is our second it is our second polygon. Then let's color it differently. Let's color it with a different color. We could color it as pink and increase some opacity. Okay, so there we go. Now, right now, what we shall do is to go back to the algebraic view. We shall activate the other polygon. This is the other polygon, polygon 1. But we shall deactivate all there. So let us also do the same. Let us also do the same for the vectors. Let us first try to remove the vectors and hide them away. It's basically hiding them, not removing them. Okay, now what we have on our software right now, it is only the 2 polygons which are active. There is the first polygon here, which is poly 2. This is another polygon which is active. Sorry, I think the other segments are back. Let me deactivate it. Then the second thing which is active is also another polygon here. Now, what I will do is I'll first try to play around with this matrix. Remember, at first I told you that there's no change in the object because this is an identity matrix. Suppose we try to change this matrix. Let me change the matrix. Here is 2. And here is 2. Then I hit enter. Okay. So let's see this. So do you people see something on the screen?
From me, I'm seeing something.
Okay. What do you see? You're seeing something bigger and something smaller, okay?
Yes. The big one and then the smaller one. And they've the same actually shape.
Okay, that is actually very good. Now, what you're seeing on the screen there, that is actually, that object has undergone linear transformation. And the linear transformation was done by this particular matrix. So the whole process that I've been doing earlier was to create some form of linear operation that will be based on this particular matrix here to create objects or to create images. This is the object. This is the object which is blue. This is the image formed due to this particular matrix. It's just like Joshua said that you have to put in a vector to give you another image. We put a vector by multiplying it by a given matrix. So we multiply a matrix times a vector to give us the object. Now, what I've been doing earlier here, when you look at this G here, this vector G, it has been multiplied by the matrix here already in the function. That's why you're seeing that all the components, all the features that I was trying to link here and there were actually linked up to this particular matrix. So which means what is happening right now is that the matrix now can detect where the image should be. So let me first try to play around with this again. So suppose I change my matrix to here is maybe -1. Then here I have it as here I have it as 1. How will my image look? Let's enter. Okay, where is my image? So there we go. So you're seeing what has happened here again is that this is our object. This is our object, and this is the image. It's more of a reflection along the y-axis. Is it true? I think it's just the same as reflection along the y-axis. So suppose maybe I also adjust this a little bit. I say this is 1, then the other one is -1. Let me see the change. I'm not trying to guess something anyhowly. I'm not sure about what is going to come. Okay, this is again another reflection along the x-axis, I guess, because I guess the distance from here to here is the same as the distance from here to here. But all this is basically done using this particular matrix. So which makes it a linear transformation. Maybe let's first see a little bit. Let me do the same thing. Okay, suppose I now give these identity matrices. Suppose here I have 3. Suppose here I have 3, then here I have a 2, and here it's also a 2. Okay, what is there? Let me reduce on the graphing space. Yeah, still. So what I want you guys to appreciate is that the matrix, it is trying to determine for us the image. The object, okay, the image and the object might change based on the matrix that you're trying to put in. You can put in any matrix there, then you have your image form in any way. Okay. So I'm soon ending, but I want you guys to also appreciate something very interesting. Suppose we use sliders. Suppose we use sliders. So suppose we use sliders into this particular transformation here. Okay. Aaron has something. Aaron, please go on. Go ahead. Let us first interact. Aaron, come here. Hello, hello, Aaron.
Okay, there is nothing that I'm going to add, but I just tap on it.
Okay, it's okay. It's okay. Let us first try to look at the concept of sliders into GeoGebra. Now, I want to create some slider for this particular slider. Slider here. So we can create the minimum value. Let me first come back again. Cancel. Okay. Control Z. Let's say it is pi. Okay, it is 2 pi. That's the maximum value. What about the minimum value? The minimum value is negative 2 pi. 2 pi is the same as 180. I mean, sorry, it's the same as 360 degrees. Okay, we have our slider here already. This is our slider. You can slide around like this. Now what I want us to do is to link this slider to our particular images. I want this slider to also try to vary our images here and there. Now, let's go to the algebraic view. That's where we have our matrix. Then I want to link this matrix together with the slider. What I will do, I will say this is cos open bracket. So the angle, I'll put the angle in the slider, which is small f. Then here I will have sine, that is still small f. But I have to delete that 3. 3 should go away. Sorry, let me do it again. So here is cos f. Then here we have sine f. Here we shall have negative sine. The angle there is still F. Here. Here we shall say it is cos F. Press the enter. Okay, let me first try to explain a little what is taking place here. Now, I introduced the slider, then later on, I was trying to link the slider into the matrix by putting in some polar coordinates. Right now, this is our matrix, and the matrix is actually depending on the slider itself. This matrix depends on the slider. So because these are polar coordinates actually, you can also transform using signs or using polar, like those trig ratios. So which means in this case our matrix is formed by, it's just formed by trig ratios. It is cos, sine, negative sign, and cos. Now let's first see what is the effect. What's the effect mainly onto this particular thing? So as I try to, this is a slider. As I try to move the slider, see what happens to the image. I hope you're seeing what is happening to my image. So which means this is more of rotation. This is more of rotation. So you can rotate this clockwise, rotate it anti-clockwise, just like that. So this is what sliders can do. You can create some particular project, then you link it up to the slider, then you make it more interactive. So sliders, this is how it goes. And even you can also do this. Let me go to the algebraic view. Let's say I'll just let it play. So if it is playing, let me see how it is playing. Let me silence this again. So you see what is happening. This is now how we make animations using GeoGebra. So if you search on the internet and see some few animations, so this is how they actually make them. They actually link them to sliders, then they keep on playing them time and again. But this is actually trying to bring for us the perspective of linear transformation using matrices. And I would like to actually stop here for this particular